In the previous lecture and in the previous video, we learned about how to draw the influence line diagram for the support reactions and for the horizontal thrust for a three-hinged arch. Now let us see that how to draw the influence line diagrams for bending moment at any section in a simply supported beam. So this is the simply supported beam AB of span capital A. Suppose we need to draw the ILD for bending moment at this section, the section which is passing through C, and this section is at a distance of small a from A support. Okay. Now this is the unit rolling load or the moving load which is moving from A to B. Suppose at any instant of time this unit load reaches at a distance x from the A support. Okay. See, we have taken the distance with respect to A. Therefore, the value of x at A will be 0. The value of x at C will be A because the distance of C from A from capital A is small a, and the value of x at B will be capital L because the distance of capital B from capital A is capital L. See, if you want to draw the ILD, you just have to find out the equation for that quantity. Suppose in this case we have to draw the ILD for the bending moment. So what you need to do is you need to find out the equation of a bending moment for two cases, when the unit load is in AC and when the unit load is in CB. After finding out the equations, just put the limits. Suppose you have considered AC part, then put the limits of A and C, and when you have derived the equation for the bending moment when the unit load is in the CB part, just put the limits of C and B. So after putting the limits, we will get some values and we will plot those values, and after plotting the values, the diagram that we get is your influence line diagram. Okay. So first of all, we will find out the support reactions VA and VB. So in order to find out the support reactions, we will use the equilibrium equations. So first of all, summation of vertical forces is equal to 0. So total upward force is equal to total downward force. Therefore, VA plus VB is equal to 1. Now let us take the summation of the bending moment about A point equal to 0. See, VA, the line of action of VA is coinciding with A. Therefore, there will be no bending moment due to VA. Second force is 1. See, this one force will produce a clockwise bending moment about A point. And for clockwise, I'm going to take as positive, and for anti-clockwise as negative. So for clockwise, this will be positive. The force is 1 and the distance of 1 from capital A is small x. So 1 into small x. Now the next force is VB. So this force is acting in the upward direction. Therefore, this VB will take A point in the anti-clockwise direction, and for anti-clockwise, I'm going to take as negative. So VB into the span of the distance of VB from capital A is capital L, this equal to 0. So the VB, so the value of VB will come out to be x by L. And therefore, put the value of VB in equation number 1. The value of VA will come out to be 1 minus x by L. Now let us find out the equation of the bending moment. Now there can be two cases, when the unit load is in AC part and when the unit load is in CB part. So first of all, we will consider that when the unit load is in AC part. So this will be the diagram. Okay. So for this case, we now have to find out the value of the bending moment at this section. See, we know that in order to find out the bending moment at any section, we have to take the summation of moments either to the left of the section or to the right of the section. So here we have taken the summation of the bending moment to the left of the section. See, you can take the summation of the moment to the right of the section also, but here I have taken the summation of the bending moments to the left of the section. And if you draw, see, this is a section and we have taken the left part. So on the left part there are two forces, VA and this unit force. The distances are these. Okay, the value of VA came out to be 1 minus x by L. Now we are going to use this sign convention. For sagging bending moment we will take as positive, and for hogging bending moment we will take as negative. And this is the section in between and this is the left force, this is the right, oh sorry, this is the left movement, this is the right movement, this is the left movement, this is the right movement. Okay, so in this case we have taken the left part of the section, therefore we will compare the movements with the left movement. Okay, so MC will be equal to C. So first force is 1 minus x by L. Now this force is acting in the upward direction, so this will produce a clockwise bending moment about this section, and if the left moment is clockwise, the bending moment is positive, so this will be plus. Now the distance of 1 minus x by L is small a from C section, so into small a. Now the second force is 1 and its perpendicular distance from the section is a minus x, so 1 into a minus x. Now this force will produce an anti-clockwise bending moment about C point, and if the left moment is anti-clockwise, the bending moment is negative, so this will be minus. After solving this equation, we will get the equation of MC, that is the moment at C section, as x into 1 minus a by L. Now, after finding out the equation, just put the limits. So we have found out this equation for AC part, so we will put the limits of A and C. So at A point, the value of x is 0. We have already discussed the values of x here. See here, at A the value of x is 0, and at C the value of x is small a, and at B the value of x is capital L. So at A x is 0, so when we will put x as 0, MC will come out to be 0. At C the value of x is small a, so the value of MC will come out to be a into 1 minus a by L. Now let us find out the equation of bending moment when the unit load is in CB part. So the diagram will be like this. Now the unit load has moved to the CB part. Now for this type of case, we now have to find out the equation of bending moment at C section. See, now in order to find out the moment at this section, we can either take the right part of the section or we can take the left part of the section. If you see the left part, there is only one force, and if you see the right part of the section, there are two forces, one and this x by L. So it will be much easier if we will take the left portion. So we will take the left portion, and in the left portion there is only one force, which is 1 minus x by L. Now this force is acting in the upward direction, therefore this force will produce a clockwise bending moment about this section, and when the left movement is clockwise, the bending moment is positive. So we will take this moment as positive. The force is 1 minus x by L, and the perpendicular distance is small a. Okay, now just put the limits. So this equation is for CB part, therefore put the limits of C and B. So at C, x is equal to a, so the equation will come out to be a into 1 minus a by L, which is the same for this case. Okay, and at D, when x is equal to capital L, the value of MC will come out to be 0. Now after getting the values, just plot the values. So after plotting the values, see, for AC part, the value came out to be 0 and a into 1 minus a by L. So here 0, and at C point the value is a into 1 minus a by L. So this is the value. Okay, so these are the 2 points for AC part, and for CB, see, for the CB part also, at C the value of MC is same, and that is a into 1 minus a by L, and at B the value is 0. So just join these lines by a straight line. So the diagram which we will get is your ILD for MC, that is the influence line diagram for the moment at any section.